All right, in this video, we are going to work through the following problem. It says use identities to fully simplify the expression. So here you can see we have quite a large expression, 3 sine cubed t times cosecant t plus cosine squared t plus 2 cosine of the opposite of t times cosine of t. So there's quite a bit of stuff that we have to work through here. So the first place that I kind of like to start is here. I notice I have the opposite of t, right? And so that just brings to mind the even odd identities, right? And the purpose of the even odd identities, or one of the purposes, is to get rid of the opposite, the negative sign inside parentheses, because you can always do that with the even and odd identities. So for cosine, right, we have this this one here, right? The cosine of the opposite of x is equal to the cosine of x. So that's where I'm going to start. All right, I'm going to rewrite all this stuff going step by step. And so right here is where I'm applying that identity. I know that the cosine of the opposite of t is exactly the same as the cosine of t by that even odd identity for cosine. All right, and you can see that kind of walks me right into the next thing that I can do here. And that next thing, I have cosine t times cosine t. That's just cosine squared t, right? So that's the next sort of most obvious simplification that I could make here. And you'll start to see, right, that the length of this expression is going to get smaller. So it's getting less complex to have to deal with. All right, next up, I can see that, hey, I have 2 cosine squared t's here, and I have another one here, so I'm just adding, right? 2 cosine squareds here, plus 1 more here. That gives me 3 cosine squared t's. So right, so those cosine squared terms are like terms, same variables, same exponents, right? So you just add the numbers out in front. 2 plus 1 equals 3. Okay, so now these cosine squareds, that's pretty simple. The sine cubed, that's pretty simple because they're sines and cosines, which are, you know, naturally a little easier to deal with than the other trigonometric functions. Here I have cosecant of t, right? So that might be worth looking at. So if I go to my identities and look at that, I can see cosecant is 1 over sine, right? So that looks really promising, right? Because if I have 1 over sine here, then I'll be multiplying and I can reduce those powers of sines a little bit. Okay, so 3 sine cubed t times 1 over sine t. All right, and that's going to be really helpful, right? Because what I'll have is, you can write this as a fraction if you like, right? What I'll be doing is multiplying these two fractions, and all of this is multiplication, right? This sine cubed is just basically 3 sine t's being multiplied together, right? It's 3 sine t times sine t times sine t all over 1. And I'm multiplying that by 1 over sine t. You can see I have some common factors of sine in the numerator and denominator. And I can cancel that, right? So I have sine t here, goes into itself once, sine t up here goes into itself once. So I can cancel out that common factor. Okay, and so then I can multiply these two fractions together. I have 3 times sine times 1 times 1. That's going to be 3 sine squared t on the top. 3 times sine, that's 3 sine squared, times 1 is 3 sine squared t. And on the bottom, I have 1 times 1, which anything over 1 is just itself, so I'm not going to bother to write the over 1 here. Okay, so this whole fraction comes out to be 3 sine squared t. This one don't forget to tag along the other expressions here. So you have 3 cosine squared t. Okay. All right. So again, this is looking much better, right? We started off with something fairly complicated, and now we're boiling it down to something that it's a lot shorter, and so therefore a lot easier to deal with. So next, ask, okay, can I simplify this anymore? Right? And you can see I have 3 sine squared plus 3 cosine squared. So looking at the identity sheet, right, for anything, you can see that the very first one is pretty close, right? I have 3 sines. I have just on the first identity, the Pythagorean identity, the fundamental one, I have sine squared plus cosine squared equals 1. So that's pretty close to what I've got. The only difference is that I have 3 sine squared plus 3 cosine squared. So what I'm going to do, right, or what I can do, is that 3 is common to both of these terms. You can factor it out. So if I factor out a 3 out of 3 sine squared, I'll get sine squared. If I factor out a 3 out of 3 cosine squared, I'll get cosine squared. All right, so 3 sine squared plus 3 cosine squared of t is exactly the same as 3 sine squared of t plus cosine squared of t times that quantity, right? So now this matches the identity exactly, and we know from the identity, right, that is equal to 1. And so this whole expression, complicated expression that we started off with, just boils down to 3. All right, so you can see that sometimes using these identities, you can take with the trigonometric functions, you can take one that looks really complicated and boil it down to something that's a lot simpler. Okay.